So we don't spend a whole lot of time on probability in this class, but probability does form the basis for inference, which is a topic that we're going to spend a whole lot of time on really for the whole rest of the semester. So in Unit 4, we are going to talk about just the parts of probability that are essential for inference. So starting with the very basics, what is probability? You can think about probability as what happens in the long run. So let's say that we flip a coin, and this time you can see it came out heads. So right now we're at 100% heads out of our one flip. If we do it again, still 2 out of 2, 100%. Again, still 100%. Wow, geez, this is really unusual actually. Okay, finally we got tails. So now we're at 80% tails, and you can see how the proportion of heads has changed, like the cumulative proportion of heads. And if we keep going, we're going to get some heads and some tails. And what this applet is doing is it's just recording the cumulative proportion of heads. So we've got, what, almost 20 now? And we're actually at 0.5 here, but it's been bouncing around a good bit. It's been mostly above 0.5, it dipped below for a little bit. But let's see what happens if we do a whole bunch. So I'm going to turn the number of tosses way up and just let it keep going. So you notice that the more tosses you get, the fluctuations are getting smaller and smaller, and that it's really sort of leveling out very close to 0.5. So here we're, what, over 300 tosses now, and it's pretty much staying steady at 0.5, and if you were to keep going and going, eventually it would level out at 0.5. So the idea of probability is if we continue for a long time, if we do a long series of repetitions, what proportion of the outcomes will be heads? That would be the probability of heads. So probability tells you what happens in the long run. It can't tell you what the outcome of your next coin flip will be. This idea that if you've gotten, say, 3 heads in a row, that you're more likely to get a tails the next time, that's called gambler's fallacy. Every single time it's 50-50, the coin doesn't remember what you've gotten before. It's actually funny because casinos a lot of times will have signs up like showing what the outcomes have been earlier in the night, but that doesn't actually make a difference. It makes people feel like they have some control, but that's not what probability is like at all. Coins, dice, roulette wheels, whatever, they don't have memory, so every time the probability is going to be the same. Probability doesn't guarantee that things are going to even out in the short run. If you flip a coin, say 10 times, maybe you'll get 5 heads, but you could get 6 or 8 or 3. This is called sampling variability, that in each set, you don't know exactly how many heads you're going to get. So because of this sampling variability, we don't want to overreact to random streaks. Randomness is going to happen. Like we saw earlier, we got like, what, 5 heads in a row, 4 or 5 heads in a row. That's unusual, but it happens. Random streaks happen. So we're going to use probability to decide whether something we're looking at is a real trend or something that would occur by chance alone.